Hello all, good morning. Welcome to the Storage Developer Conference India virtual session. And today the topic that I will go to discuss with you is unstructured data management and emphasizing more on the performance considerations for the same. So I work with Comprise. It's a small startup specializing in unstructured data management with all the intelligent analytics that helps our customers solve all the challenges that comes with the unstructured data management terrain. So let me just jump into the topic now. So what is unstructured data and what is its relevance? So the chart here can give you a brief overview that today all the data that we have generated, a majority of that, as high as close to 80% of that, generated both in the organizations and by the users, is predominantly characterized as unstructured data. So what is unstructured data? Something that we cannot readily store in rows and columns. All the images, the audios, the videos that you can imagine. And this is definitely not going to be stored as relational databases. It requires more file systems and more unstructured format. And this is where all the NAS filers and the object store come into the place. But the challenge is, how does the user make use of this? How does the user derive analytics out of this and answer the more difficult questions? And on the right, you can see, typical file management questions that the customers would like to have. The answers are like, which user is consuming more space, right? So that based on the user needs, the unstructured data can be stored or recorded in its relevant tier and with the right time at the right location. Then which applications are consuming more space, right? So you might be better equipped if you know which are the applications that are more sensitive towards the storage, towards the performance characterization of that storage, and how much space is being allocated for which kind of files, right? How many files are there under a given directory? And when was the last access time? What is the relevance of this file? Do we still need to keep it in the hot tier? And all these kind of questions that one can visualize for an unstructured data. This is where the current market challenges are being posed. And this is where my current interests lie in trying to see how we can optimize the management solutions to better serve the unstructured data space, right? So let us see what happens if the data management is not very robust for unstructured data. So as you can see, all the interconnected problems start arising. So one is the infrastructure costs start shooting up because you tend to store all of them as multiple copies. You take up frequent backups of these unstructured data. And this can start sprawling your data center within no time, right? And then comes the security challenges if you have not been watchful of the location of this data, and if it is there all over the place, and that will lead to compliance issues, and then it definitely loses the productivity or the business strategy requirements given the vast amount of storage that you are occupying, right? And what are the typical customer pain points? As you can see, customers typically come to us with a handful of, repeated problems. So what are these? They want to reduce the costs. Across the company, the storage cost reduction still remains to a great extent the number one problem at hand, right? And then the second thing is, even if you have spent a lot on this data and the storage, what is the analysis, and are you able to visually make an aggregation and make some business decisions out of it? That is where the customers would like our help to solve this problem. And then application performance, whether all the files, objects that the users have created and being stored across all your NAS filers, object stores, are they giving you the intended performance? Are you getting the buck for return over buck for the storage that you have invested. That is where application performance has to be considered. And then after we make an assessment of all the data that we have, can we make some policy-driven mechanism so that we know what is the life cycle of this unstructured data and what can be done to further prevent the sprawl, or can we use this data more in an optimized way by making more business decisions as to whether we should retain it, whether we should send it to the cloud, tier it. All of those problems are something that customers repeatedly come to us, right? And just to summarize, what is happening is in the backend, the cold data is, occupying all the storage space, which otherwise could have been reserved for, all your hot data, something that has been in use actively and something that your customers really care, right? And if you don't have an insight into your data profile, you would land up in a lot of unstructured storage silos, which doesn't help the data center admin or even the business who has invested in the storage, right? So we need to find a more cost-efficient solution to optimize the data and the storage, right? And the lifecycle management is a key concern that one needs to keep a watch at, right? And without any intelligent analysis, the data modeling or the data usage will go out of hand in no time, right? And even your backup storage system. So this is important. So if you don't categorize your data into hot and cold across your file systems, what will happen is you tend to typically keep multiple copies. I think the minimum is 3 copies of your data, both for replication, backup, archival, and you can visualize the cost that it will incur for maintaining all those multiple copies. So these are some of the threats posed by a poor data management strategy. And this is where multiple vendors have started to make a note of this problem, and there are multiple contenders, and they come with their unique competencies, right? So I just picked up this chart which shows the list of vendors who are trying to solve this problem that we just discussed, right? And all of these vendors typically have a few criteria to be judged before the business makes a selection as to which vendor should be partnered with. And at a high level, the points that one would be really watchful is, what is the architecture that this vendor brings onto the table? How can we solve the problem at hand? Of course, for whatever unstructured data management solutions, what is the best case architecture? Is it a scalable one? Do we need to invest as we scale out? Is it a scale up? Is it flexible enough based on the consumption? As the number of filers increase, as the number of shares to analyze increase, do you have that leverage of scaling the solution or not? And then, of course, the same next thing and the most important thing is does it honor all the performance criteria that you would have set based on your business requirements? So if you make a business decision to go ahead with any one vendor, but if it doesn't really guarantee the level of performance, so that would not be a very wise investment if the performance is not up to the mark, right? And then, of course, does it have a usable management interface? Is it easy to consume for the end user? And does it really bring down the total cost of ownership over time? So these are the top criteria that one needs to look at for a given vendor. And you can see that the classification of vendors is out there, how mature they are or how innovative they are. And you can see a lot of startups trying to pitch in this space and solve the overall unstructured data management space, right? So next, let us see what are the typical workflows involved. And I'll just keep it vendor agnostic. I'm not going by any specific vendor or just to avoid any marketing pitch here. So typically you would see that we would have the product or the architecture distributed across both on-premise and in the cloud. So what do we need from on-premise? We need our data movers or the crawling agents or the scanning agents, whatever you may call, which are co-located right beside the source of data, and that is NAS in this case. It can be a SMB filer, it can be an NFS filer. So we need to be co-locating our analysis or the scanning utility just adjacent to these sources of data. And this is keeping in mind, the latency requirements. And you'll see that there will be a discovery or the scanning engine who will initiate the call to these filers, and these filers will then share their metadata to these data movers or the scanning agents. And then these scanning agents will further send this metadata and classify this metadata and preserve it in a metadata persistence layer, right? And from this on, the next stage can be in cloud, wherein you make more analytics out of this metadata. You know which kind of files are residing in your storage, what is their characterization, when was the access time, when was the last modified time. And if you want more deeper analytics, all those utilities can be built once you have that robust metadata storage, right? And then your customers can connect to this using the cloud console and make relevant business decisions, whether I need to tier the cold data, whether I need to migrate some filers from one source to another source, whether I need to keep a replication as my strategy. So all whatever you can think of as a data management use case can be decided based on the analytics that you derive out of it. Right. So now, considering that this is a generic architecture, of course, there might be changes. Some architectures might be more involved, and I just kept it at a very high level. But then at the end of the day, most of the vendors would have the architectures somewhat in this fashion, right? So now the interesting part is, let's look, given the architecture, what are the performance considerations? What is the cost that you will incur if the algorithms are not optimized, if the data structures are not optimized? And what are those penalties that one needs to bear in mind before making a good choice of the software solution for unstructured data management? So one of the common things that any vendor would want to undergo is crawling of these file systems. So whether you do it at a share level, whether you do it at a directory level, whether you do it at a filer level, so crawling and scanning, this is a underlying bedrock of the intelligent data management solutions. So why do we need to crawl? Can we not take the data, say, from something like snapshots? Can we just not have an easier mechanism to understand the metadata? So in most cases, it's not that straightforward. And that is why you need to be watchful of what are your algorithms that you're using for crawling the file systems. And why do we crawl? We need to track the modified time, the access time of the files, and then collect this information for our end users to make a business decision, right? And this is not really easy for large file systems wherein you run into billions of files. And this is where the crawling really starts to become an architectural focus area, right? So what is an ideal scan? An ideal scan would be something wherein you only crawl through the files whose metadata has changed. Every time you don't need to go and crawl the entire file system or the share, that would be a lot of penalty both on your client that is crawling, as well as the target filer, which is otherwise busy in the production workloads, right? And that is why you need to keep the impact of this crawling to a very minimum, right? So doing a full scan every time might be time consuming, as high as hours or even days, based on the number of files and the density of files, right? And this is where most of the solutions come up with a throttling mechanism, say, for a scheduled scan, which might happen once in a week or once in a couple of days, you might want to allocate higher number of threads to complete this crawling operation. But if you're doing it on demand, something that you added a new share, and on demand, you want to scan it on the fly, that is where you call it as manual scan. And for manual scan also, you would want to allocate threads based on the internal assessment and the performance penalty that you see for a given density of file systems, right? And the other challenges is, even the best of the best crawlers can run into issues if the file systems are so deep that it doesn't honor the recommendations of the directory depth. You might have directories within directories, and in those directories, a chain of all the files that are existing. And typically, if you exceed, say, a predefined limit for the file system, say around 1 million, that is where the crawling starts to show up, the slowdown. And this is where you need to bear in mind, whenever you are going ahead with finalizing crawling algorithm, do you have a checkpoint to see how many folders or how many depth of files that you can possibly honor for the given architecture. So at a high level, crawling is something one needs to bear in mind whenever you are designing or testing or baselining any solution for unstructured data management space, right? So typically what we want to do intelligently is have an adaptive crawling. So what this means is, on the left, you can see that, you might have multiple agents doing your crawling, and they will spawn up multiple crawl threads, right? So each of these are like clients for your ultimate NAS server. And these clients typically will use the kernel or the user space NFS clients service to invoke these threads, go and walk into your file system, see the directory depth, and make a pattern out of it, right? But then you're imposing a good amount of penalty on both sides if you don't keep a watch on the number of crawl threads. So this is an important consideration as a performance engineer you need to have, that you're sensitive to the end user, you're sensitive to the target file system as well, right? And what you could do is you could poll the latency stats for your file system and see if you have to increase the concurrency of threads or decrease it based on the need. So that while you're doing your crawling, which is again not for a primary use case, right? So your end customers accessing the shares wouldn't care whether you are doing the crawling for metadata creation, whether you are doing it for the storage optimization. All they care is whether I'm able to reasonably access my shares or the files in a given time frame effectively. And this is where adaptive crawling is one of the key concern and a key consideration, I will say, for unstructured data management. Of course, I have kept it at a very high level, but then this is something that is a repeated challenge that we see across vendors, right? And how can we optimize this? So now, without knowing the entire architectural stack, it is difficult for a performance engineer to validate, how we can go and optimize or improve the things. So this is where I have just listed out what can be your first level of mechanism is to first go and scan what's happening between your NFS client and NFS server. Of course, the popular tools out there are, Wireshark, which will intercept all your TCP/IP connectivity calls happening between your client and the server. You can see which are the typical calls that are being made every time you are opening up a crawl session, whether you're opening up a file movement, whether you're reading a file or writing back to a file. All of those calls are enumerated by the Wireshark. And of course, there are other easy to use tools like, say, Prometheus and Grafana family that I have listed on your left, which will tell you exact number of calls, the type of calls that we are making, the RPC or the TCP in this case, and whether you see a repeated loop of calls. Can you optimize this? Can you write something on your own from the NFS client and make all your crawling and scanning the file system more effective, right? Typically, if you see Linux native kernel NFS client is not really built for, the parallelism that you would anticipate. It's not really for high performance that in this case that you would want, right? So what we can see is we can inspect if there are any calls which are happening redundantly, which you might do away with intelligently. So this is where the Wireshark analysis comes into the place. And it might also happen that you write your own custom NFS client to overcome this kind of limitations, right? So in essence, the takeaway is, for an efficient crawling, you need to do validations at the TCP layer, see what's happening between your NFS client and NFS server, what are the performance implications based on the given architecture that you are pursuing, and then improve from that stage, right? So this is what we call methods to improve the crawling for your eventual architecture. And then once you have the crawl and the metadata in hand, so it is not just good enough to have all those analytics and not make business decisions. So this is where customers would want to tier their unused or the cold stage or the uh, cold file systems that have not been accessed for a while, say in the last 1 year. And typically we see nearly 60 to 70% of the files in a filer are not accessed in, say, around 6 months or even 1 year. So the best thing would be to tier it to a more cost-effective storage. In this case, it can be an S3 bucket, something based on the cloud targets, or it can also be, another cheaper NFS tier itself, which will save you a lot of capital expenditure, I'll say, right? And what are the considerations that the vendors would make, and what you need to be watchful is, when you're moving the files, the time taken to move is something customers would be sensitive, and it depends largely on what is the nature of your files. If you have large number of small files or small number of large files, that would really determine, what is the time taken for you to really make this archival process smoother. So if you see, the performance of moving and copying small files is really a challenge. The reason is not really to move the files itself, but it is to move the metadata associated with these files. If you have large number of small files, the metadata is scattered all across the storage blocks, and you need to be able to gather that metadata and then move it to the target along with your file as well, right? And this is where you get the whole operation slowed down. So if you can see, transfer of small files is really something that you need to be watchful of, whether you can optimize your data structure or the architecture itself to take care of this thing. So of course, large file has another set of characterization, but then most importantly, the large number of small files will be a concern. And some of the workarounds that vendors might apply for this challenge is, not every time do the file copy and the metadata copy serially. What you can do is make a selection that in a batch, you can transfer all the files in one go and then metadata in another one chunk, right? So that you're not waiting for the sync time before every file copy moves. Rather, the metadata is moving in one go and not going serially. So this is one of the approaches you can keep a watch. Of course, all of this is determined based on the backend performance validations that you would do, because any decisions like this would be dependent on the numbers that you are able to generate in the lab, how effective they are, and if they are making a good sense, that would be the ultimate choice to make, right? And then once you move these files, customers might not really access them frequently, but when they do want to access it, what is the read access and what is the efficiency of reads that you're able to give? Say, if I have not accessed my file in the last 1 year and it is going and sitting there somewhere in the S3 bucket, say for some compliance or for some regulatory purpose, if I have to bring that file back, whether I need it temporarily, whether I need it permanently, that is a second level of consideration. If you need it temporarily, you don't have to move the whole file back all the way from S3 to your primary filer, right? You can predominantly cache all those files in your intelligent data movers or the interim components. But if you see that you are going to access that file more frequently, that is where you make a decision to completely move the file from the cache tier. And some of the considerations that as an architecture for unstructured data management space you need to make is, any processing that you're doing should be within the defined limits. It should not be that your software is making more calls to access a simple archived file, which will be counterproductive to the customer. And you define the access time. You can say, for the average files of X amount of kilobytes or megabytes, this is the typical access time, and make an assessment whether that is good enough in line with the regular production access times or not, right? So all of us are sensitive to bandwidth, and hence we need to check whether our target and the source are in line for whatever decisions that we make. You have to do throttling at multiple levels and see whether your file reads are well within the business requirements, right? And after all of this, you can devise a strategy or from the architecture point to make an efficient read mechanism in place. So all in all, what we saw in the last 10 to 15 minutes is what are the challenges associated with unstructured data management space? What are the penalties that customer would have if it is not managed well? What are the business implications if you do not have a data management strategy in first place? And then we went towards performance considerations for archiving the data, for doing a crawling of these file systems, and then for the read considerations of these crawled files. What are the top things that one need to consider? So pretty much these are some of the repetitive things that one can keep an eye on, whether you are a performance engineer or whether you are a developer. These are some things that you need to bear in mind to make a efficient data management platform, right? So this is what I had to share with this audience. This was a quick 20-25 minutes conversation that we had. I hope it will help you to further visualize and make better architectural decisions. So thank you for your time, and I appreciate your feedback, if any. Thank you.